Hi guys, it's me, Samuel McDonald, for probably the last time with.
Mr. Byrne.
Hi.
Alright, so the first question that we're going to ask you at your conference that you went to in April is, what was the name of the conference and where was it located?
Okay, the name of the conference was the 2017 Conference in Astrobiology, and it was sponsored by NASA, and it was located in Mesa, Arizona.
Alright, next question. Why were you invited?
Well, I've been working on a theory about the evolution of intelligent life in the universe for the past couple of years, especially during the summer. And I thought back during the winter I might submit it to a conference. So I submitted the abstract, which is a procedure. And the conference committee, they get the abstract, they review it, and they decided whether they want to invite your paper or not, and they invited my paper.
Alright. Who was in attendance? How many?
It was a who's who in science and astrobiology, meaning some famous people and some very well-known, brilliant scientists, like Dr. Paul Davies. I have several of his books, and he's a physicist. He's now at the University of Arizona, including some of his books in my collection, The Mind of God, God and the New Physics. So he likes to look at the possibilities, for example, the existence of God from the perspective of science. He's a real innovator. So I got to meet him. Another one of my favorite authors, Dr. David Grinspoon, who's also the chair of the astrobiology department in the Library of Congress. And so I've been reading his book. So we connected at the talent show, and I showed him some painting. And our mission, he loved our mission statement. So he mentioned that if you're ever in the DC area, look me up and we'll get together. So that was very, very nice. But we had about 800 astrobiologists in attendance.
That's nice. Alright. What is your fondest memory of the conference?
My fondest memory, okay, you'd think it would be my science presentation, but it's actually the talent show, because I had 800, but only 8 of us signed up. But the other was Dr. David Grinspoon, who was also a very talented musician and blues and guitar, and he sung this very entertaining song that he composed himself called "I Have the Astrobiology Blues." And the theme of the song was, they're doing all this research, but yet we haven't yet discovered why. It was very entertaining. I got up and I performed "Put on the Ritz," the taco version. So we kind of connected over that, so we had this great conversation after. That's how we got to know each other.
Right. Who did you meet? Or how did you meet?
Well, that's how we met. We met at the talent show. And also we exchanged some emails and we invited me down to Washington, D.C.
Cool.
What did you learn as a scientist?
Well, I learned, first of all, reinforced the idea that I already have, what I believe. We're moving into a whole new era in science. It's not just about the Earth and us and 8 planets. It's now about 5,000 exoplanets, and the number grows every week. And possibly billions of planets just in our galaxy alone. We believe that planets are more commonplace in the universe than we think. In fact, almost every star would have a planet. So it seems, given the vast number, that other biospheres are almost unavoidable in even intelligent life. But I learned just in our own solar system, places like Mars, that some of these scientists believe it's just sterile. Forget about Mars, we need to look other places, but some of the astrobiologists at the conference are holding out with some possibilities. For example, we're seeing what's called a biomarker, like these methane plumes, which may be an indication of life. Like bacteria, for example, they emit methane. So we're kind of holding out for Mars. And also Ceres, the dwarf planet in the asteroid belt, has some interesting features. Basically a frozen mud ball. It's an ice-coated mud ball. So what's happening inside that mud? So in astrobiology, where there's water, where there's life, there has to be the possibility of life. So looking at the possibility of at least microbial life in a place like Ceres, not that some little green man will come popping out with a laser, but certainly very primitive life. Another interesting object was Europa. So what is happening under that very thick layer of ice that covers the ocean of Europa, which is, we think, is 2 to 3 times the volume of the Earth's ocean. in my opinion, it seems like there's got to be something happening down there. Maybe even complex multicellular life. Probably not intelligent life, like intelligence that would produce technology, but maybe something more in the order of dolphins and whales and that kind of thing. And I think, hopefully before the end of my lifetime, but most certainly before the end of yours, we'll have the answer to that question. And also looking at other exoplanets, like, for example, the TRAPPIST system. There are 8 Earth-like planets. We have to see a signature for life. We call it biosignature. One of the things we look for would be the element of water. We're not seeing a lot of that in these planets just yet. But still, there are possibilities.
Cool.
All right. What did you learn as an educator?
So a whole workshop was, a whole day was devoted to workshops just on education. So how do we teach astrobiology in the classroom? So it wasn't just about listening to this research by these other scientists. So we here in Weymouth High School, in our class, were very much on track in terms of our having this 21st century perspective on science and on the biosphere and our place in the cosmos.
All right. So what are the possibilities for life elsewhere in our solar system?
As I mentioned previously, some of the hot spots would be Ceres, the dwarf planet in the asteroid belt, which is about roughly 900,000 miles in diameter, and also Europa, maybe Titan, maybe some other objects, but they are right now the hot spots in Mars. We're still holding out for the possibility for at least microbial life on Mars, in spite of the fact it's basically a frozen desert.
Cool.
All right. What are possibilities for life on the discovered exoplanets?
Yeah, so as I mentioned before, you think out of 5,000 planets, there's got to be at least something happening there in terms of organic chemistry, maybe basic life forms, like something, again, on the scale of bacteria, amoeba, that kind of thing. But when an object is light years away, 20, 30 light years away, and even greater, it's very, very hard to see. So we need, for example, the Kepler telescope is able to resolve some of these features in deep space, but it's really hard to discern the details. But so we haven't, an intelligent signal, like a radio signal, an alien signal, we haven't heard, detected that yet. But in terms of primitive life, there's still some possibilities in some of these exoplanets.
Oh, yeah.
Like, for example,
So
the
nice.
TRAPPIST system, the Galax system as well. They're also Earth-like planets.
All right. How do scientists research the possibility of extraterrestrial life?
Okay, so like, how does a scientist research something that doesn't exist yet? We have yet to discover astrobiology. I mean, the only biology we know about is right here in our own planet. Okay, well, we go to places on Earth, for example, that might mimic some of these environments in the solar system. Like for Europa, basically a frozen ocean, we do some experiments down in Antarctica and study the environments in that location. Deserts like for Mars. So we find these analog environments that we study and maybe do experiments. And also we run computer models, computer simulations of how these environments might behave.
Tell us about your Janus hypothesis.
All right, so my Janus hypothesis really focuses on the role of intelligence. Okay, so once intelligence emerges, now keep in mind we're not the only intelligent species on the planet. There are also many forms of intelligence.
Yeah, like pigs.
Dolphins, whales, I mean lots of animals, even ant colonies are very sophisticated. But what I mean by intelligence, an intelligence that can produce technology, in other words, some device that can send a radio signal into space, like we have. So once that emerges, given the right conditions, then it really kind of takes on a life of its own. So it becomes self-organizing, self-replicating. And then it begins to move through stages of organization. So for example, right now we're on the planetary stage. So we're basically stuck on our planet. We're just putting our little baby toes out into space. Like we run a few astronauts on the moon, we get satellites, and we're sending out probes to different parts of the solar system. But eventually, when we start colonizing, maybe before the end of your lifetime, we'll start colonizing some of these objects in the solar system, like Mars and maybe some of the moons. So now we're on the interplanetary stage. And then the next stage, maybe for us in the distant future, but who knows, there may be civilizations right now, somewhere in the universe that have achieved level 3, which would be interstellar. So, like in Star Trek, like exploring other star systems and colonizing planets, like some of these exoplanets, for example. And then the last stage would be galactic. So imagine a civilization that is at the galactic level. So in other words, they have populated a whole galaxy of stars. And we're talking about hundreds of billions of stars, and be able to tap the energy from those stars. Because as civilization becomes advanced, as its technology becomes more sophisticated, as its population grows and expands, the energy demands will rise exponentially. That's one of the things we're contending with here on Earth, and trying to meet those demands of burning carbon and modifying the environment. So Carl Sagan asked, well, what would a civilization 1,000,000 years look like? Like us, we humans, or Homo sapiens, the species, we've been around for a couple 100,000 years. And I have an announcement there, folks, in case there's noise in the background. Sorry about that. But modern civilization really for the last 10,000 years. But imagine 1,000,000 years and what these technologies are capable of. So I have illustrated here, for example, how do we meet those energy demands? An object called a Dyson sphere. And this idea was developed by the physicist Freeman Dyson. So what greater source of energy than our sun or a star? So to be able to build a shell around that star and trap that energy, be able to tap that energy. So this would be on the interplanetary and interstellar stage, in advance of ours, of course. And to get to some of these stars, well, how do you populate stars that are like light years away? Right now, it would take our technology, with our present rate of speed, about 150,000 years to reach Alpha Centauri. In fact, I think one of our students calculated 279,000 years. That's almost 900 generations of humans. Many more times the number of generations that have lived on Earth so far. Well, how do you overcome those distances? Well, what if you can exploit, like Einstein's general theory of relativity, to construct really, in effect, artificial wormholes? The wormholes may form naturally in the universe, but what about an artificial wormhole, which is called an Einstein-Rosen bridge? And this object is predicted by Einstein's field equations, and in fact depicted in the movie Contact. So Dr. Arroway is transported from the Earth to the center of a galaxy to interact with a holographic version of her dad, and then return to Earth in 18 hours. A journey that otherwise would take many millions of years, plus mobile technology. So also, I compare this, I use the chaos theory to describe this increase in organization. So in other words, intelligence, kind of like the clouds outside, act as a chaotic attractor. Okay, so if you notice these stratocumulus clouds, no two stratocumulus clouds are exactly alike, but they have the same basic form. They're kind of puffy and cracked. And so intelligence would behave the same way. So each biosphere with this intelligence would be unique as it continues to evolve under different boundary conditions.
All right. That's at the end.
Yeah.
Do you have any more questions for me, gentlemen?
You.
No.
All
I'm doing good.
Well, this is Samuel McDonald with
Mr. Byrne?
and
Me. Sorry.
and.
Brooke over there.
Hi, Brooke.
Hi.
Alright, so I'll see you guys this week on his channel. Maybe you'll have some videos on my channel too.
Yep.
So, and if you want to end off with what you're going to do on your channel, you may.
Alright.
Go ahead if you want to do that. So you're on your channel if you want.
See ya.
Yeah, okay.